Assalamualaikum dan salam sejahtera. Minggu ini kita akan masuk chapter 2, which is capacitor and dielectric. So in this video, I'm going to explain the first subtopic, 2.1 capacitance and capacitors in series and parallel. So first of all, we need to know what is capacitor. So capacitor is a device that stores energy or charges. So here it says a device. So device ni macam power bank. Power bank stores energy. And capacitance pula is the ability of a capacitor to store an electrical charge or energy. So senang cerita, capacitance is actually the value for capacitor. Okay, capacitor, the symbol is, okay, this is the symbol for the capacitor, which we have, okay, positive plate and negative plate here. And this positive plate stores the same charge. So in order to find this value for capacitance, C dekat sini, value for capacitance, then kita akan gunakan formula C is equal to Q over V, where Q is the charge on one of the plate, and then V here, potential difference across the two plates. Maksudnya dekat sini, Q ni, kita hanya ambil charge daripada satu plate sahaja. So if here positive and negative, we just ignore that one. We only take 2 micro here. So, and V is the potential difference, which is the delta V across the capacitor. And the unit, okay, unit untuk capacitance adalah farad, F, or coulomb per volt, C per volt. But usually kita selalu gunakan F sahaja. Okay, now we look at capacitor in series. So let's say we have 3 capacitors, okay, and these capacitors are connected in series to a battery here. Okay, kita connect 3 capacitor ke battery dekat sini. Okay, so this capacitor, setiap capacitor ni akan ada value capacitance dia sendiri. So, okay, when this capacitor are connected in series, okay, the charge, okay, across all of these 3, which is Q1, Q2 and Q3, is the same. Charge tidak akan berubah, dia akan sama. So QT, which is Q total, will be equal to Q1, will be equal to Q2, will be equal to Q3. So let's say if we have another capacitor, Q4, sama juga. Q4 pun akan sama. Okay, now the potential difference. Potential difference, okay, for each of these capacitor, okay, setiap capacitor ni dia ada voltage dia sendiri. So this voltage, okay, how do we determine this voltage? Okay, total voltage VT, which is this one here, akan sama dengan V1, V2, V3. So let's say if I put here 12 volt. So meaning that V total, okay, meaning that here V1 plus V2 plus V3 akan sama dengan 12 volt. Okay, so if we want to find the total for all of these capacitors, kita mau cari dia punya total capacitance. So we are going to use, okay, this formula here. Okay, effective equivalent is the same with total. So dia ada 3 nama lah. Total, equivalent, effective, benda yang sama. So if we want to find the total capacitance, will be equal to 1 over C1, 1 over C2 plus 1 over C3. So if we have another capacitor, sama juga plus 1 over C4. So apabila kita sudah cari the total capacitance, okay, we can simplify the circuit into like this. So now kita sudah total up ketiga-tiga ni, kita hanya akan dapat satu capacitor with the equivalent capacitors. Okay, okay, and then the voltage will be still the same, which is 12 volt. Okay, next one is when the capacitors are connected in parallel. So there are 3 capacitors here, which all of them are connected in parallel to each other, and they are all connected to a battery here. Okay, macam yang Miss cakap, setiap capacitor ada value capacitance dia sendiri, dan value voltage dia sendiri juga, dan charge juga. Okay, for parallel, charge dia pula dekat sini, okay, the Q total will be equal to Q1 plus Q2 plus Q3. Sekarang dia punya charge tidak sama sudah, sebab they are now connected in parallel. So kita kena tambah setiap charge from each of the capacitor. but the potential difference will be the same. Potential difference dekat sini V1 akan sama dengan V2 akan sama dengan V3, which is sama dengan the potential difference across the battery. So let's say here which is 12 volt. Maksudnya VT is equal to V1 equal to V2 equal to V3, which is equal to 12 volt. Okay, potential difference akan sama. Now if we want to add all of these capacitors, okay, kalau kita mau tambah cari total capacitance untuk parallel, kita hanya gunakan C effective is equal to C1 plus C2 plus C3, just tambah sahaja. So lepas kita sudah tambah, kita akan dapat satu simple circuit with only one capacitor, which is here adalah C equivalent, which is the total lah, value for the total setelah kita sudah tambah ketiga-tiga ni. Okay, last one we look at the energy stored in a capacitor. So we know that capacitor function dia adalah to store energy. So this energy store, okay, will be equal to the work done to charge it. So dia adalah equal kepada work done. So what is the formula for this energy store? Okay, we need to know how to derive this formula. Okay, so how do we derive this? Okay, first of all, okay, dia adalah dW, which is the work done, which is equal to V dQ, and V here is equal to Q over C. So ni adalah formula yang awal-awal tadi lah, formula of the capacitance. So integrate this dW, okay, integrate both sides. So masukkan Q over C dQ. So apabila integrate, we get W will be equal to 1 over 2 Q square divided by C. So okay, work done dekat sini adalah sama dengan, since dia cakap sama dengan energy store is equal to work done, right? So dekat sini maksudnya U akan sama dengan 1 over 2 Q square over C, which is this will be the final formula for energy. Also kita ada another formula. Okay, kalau kita masukkan Q dekat sini, which is equal to CV. Okay, kalau kita masukkan Q which is equal to CV, akan dapat the next formula here, which is U is equal to 1 over 2 CV square, and also kita boleh gunakan U is equal to 1 over 2 QV. So formula ni tidak diberikan di dalam exam, so you need to know how to derive the formula ataupun hafal lah formula ni. Okay, now we want to know the energy loss in the circuit. So energy loss sama dengan UB, which is energy produced by the battery, minus with UC, which is energy stored in a charge capacitor. So kalau kamu tengok dekat sini, okay, formula untuk energy store in capacitor adalah 1 over 2 QV, but energy produced by the battery adalah sama dengan QV. So let's say the battery, okay, produce energy 12 joule. So this capacitor only store the energy, okay, only store half of the energy, because 1 over 2 dekat sini kan. So meaning that U is equal to 1 over 2 times 12 joule, which is 6 joule only. Okay, so okay, we are going to use this formula here for energy loss. Okay, that is all for 2.1. Okay, we are going to discuss the example in the next video.